Hey folks, how's everybody doing today? So I have a bit of a funny story. I was supposed to go to common space work, and I get there and I hit the button to unlock the door, and apparently I'm not allowed access during the weekends, only the weekdays. I had no idea. I used to be allowed access during the weekends, but yeah, so turns out I can't actually get in. So I don't know if anyone has shown up or wants want to do that. But if I mean, I live in the same building. I live upstairs, so if anyone can let me in, I could probably go down and say hi. But uh, no big deal if not. So I'm good to get started here. I see Dominique. It says you have your hand raised.
I do. I just have a quick question that's off topic. And careers in code classroom, I have a note from, or not on so much as a note, but assignment that says test assignment. We're testing something, folks. Hang tight. That's been in my file for maybe a week and it's due the 23rd. What is he talking about?
So I don't think that's something you have to worry about. I know Jesse and Max were playing around with different ways of doing assignments, like grading point values and stuff like that. I think that's what that's about. Um, if you want to be totally sure, post something in the channel and Jesse can confirm. But I haven't heard anything about it. I don't think you need to touch that or worry about it.
Okay, yeah, I just wrote him a note in the assignment, just asking him I'm confused, what's going on. So he'll answer back. He usually does. Thank you.
Yep. So I have a feeling that folks are going to want me to go through promises. Am I right in that assumption? I see a lot of head shaking. Or so. Okay. So I guess I think before I go into that, in general, do folks understand callbacks? That whole concept.
Yeah, I'm still trying to like process some of the stuff from module 4. And I'm actually going back through assignments that I owe Max and that I owe Gus and trying to really get this stuff. So I'm like, the only callback I know is when someone calls you back.
Okay.
No, I could use, if other people could as well, could use a little bit. And if other people are good with it, then we can do a private thing. So, but yeah, I'm
I'm
totally
I'm
not.
seeing I think a lot of people are in the boat you're in right now, Carolyn, where they like kind of understand it but don't really. The thing is, in order to really get promises, you have to really get callbacks. Like that's a kind of a core foundational concept. So let me start by going through that. And I think if you guys can understand that, then I I think there's a way we can get to promises, if that makes sense. Okay. I'll be honest with you. I didn't really put anything together, so I'm just gonna kind of uh, go through it again and like interrupt me with questions. Like that's what this is for. So let me get something here. That. okay. Let's make this really big. Very nice. So the most important thing to start with callbacks is that in JavaScript, there's sorts of two types of operations you can perform, what are called synchronous operations and asynchronous operations. A good example of a synchronous operation. Say I write like a function add, takes like A and B, returns A plus B. When JavaScript runs this add function, maybe like add 1, 2, something like this, result, make this have some syntax highlighting here. When it runs this add function, it's going to give it 1 and 2 for A and B. It's going to compute their sum, and it's going to return it immediately. It's going to store that result into that result variable. Now, this is something the computer can do. It can run through this step by step and do it sort of as it's running the code. It can invoke this add function. It can give a value to A, a value to B. It can sum those two values together. It can return it. It can put it into a result. That's all stuff that is kind of happening as the code is being run. Now, most of the code you've written so far has been synchronous. So to you, this probably just seems like how all code works. But there's another kind of operation. Let me label this synchronous here, which is asynchronous. And probably the best example of an asynchronous operation is like something we talked about in this module, making a request to a server. And the reason why it's asynchronous is there's not really a way you can do something this directly to make a request to a server. What do I mean by that? Well, when you make a request to a server, what do? Well, you start off by opening up like a connection to the server, like what we did with like netcat module 5.ml 5000 or whatever. So you first have to make a connection to the server. Then 2, you have to formulate your HTTP request. So that's like taking the data you pass to whatever, taking the data and turning that into like the get, the path, HTTP 1.1, like making this sort of thing. Then you have to take that, you've got to write it to the connection. And then here's the big part, the reason why this is asynchronous. You then have to wait. You have to wait for the server to go through, to take that data, to do something with it. And then eventually, after some amount of time, the server is going to send back a response. And then once they send back the response, you can then parse the response, extract the status code, the body, all the sort of important metadata. And then once you've actually parsed it, you can then do whatever you want with it. You can log out the status code, log out the body, you can write the body to the screen, you can do whatever you want there. And for the most part, this is synchronous. The thing that makes this asynchronous is the step 4. So this is the important step. These all are synchronous things. Making a connection to a server, the code can just do that and move on to the next thing. The same thing with 2, same thing with 3. But this waiting, there's really like, you can't just like run a line of code to wait. Like you have to, it's kind of just intrinsic to the operation. You have to wait for someone else to give you a response. And because there's this wait step, this whole operation is asynchronous, or it has to be, because this is part of it and this part is asynchronous. So the whole thing is therefore asynchronous. Does the difference between this sort of concept of like this sort of operation and this sort of operation, do you understand like the difference there? I need to have the chat open so I can see if people are saying things. So Carolyn, you said, so the add 1, 2 corresponds to the respective positions in the parameter for add A, B. Yeah, exactly. So 1's going to be A, 2 is going to be B. Cool. I'm seeing a lot of yeses. So let's just to kind of prove the point, let's try to write this in a synchronous way. Like write this as you would think it would work, probably naively. So I'm just going to add things in between here. So I'm going to say like make a connection to the server. And I'm just going to, so it's not an index, but a parameter. Yeah, so I call the function add. And when I call the function add, it takes 2 parameters, A and B. And I'm giving A the parameter, the value of 1, and B the value of 2. Making connection to the server. I'm just going to kind of make up like roughly what the JavaScript would look like for it. These aren't like actual real things, real like APIs that exist in JavaScript, but I'm just going to make it up so you get an idea of like what it would look like. So say like connection. It's like make connection to like module5.ml 5000, something like that. And then maybe like HTTP data is equal to like method plus that plus path plus HTTP 1.1. There'd be more, but you get the idea. Write it to the connection. Maybe you go something like connection dot write HTTP data. But how do you write like await? So one thing you can do, and this is something that happens in other programming languages, is there'll actually be like sort of a loop where you might do something like you'll make like an infinite loop, and then you'll like wait for some amount of time. Oh, the autocomplete's having fun with me here because I'm not actually using real things that are defined in this file. So like maybe I'll wait for like 1 second. And then I'll like check to see like, has the data come back yet? And then like if it has, then I'll like break out of the loop. I'll break out of the loop or something. Const data has, yeah. So you could do something like this. And other programming languages will do something like this. The reason why this doesn't work in JavaScript, though, like just kind of like spinning, like waiting, like kind of like the kid asking their parent who's in the back seat, like, are we there yet? Are we there yet? That's that sort of approach of like, has the data come back yet? Has the data come back yet? The reason why it doesn't work in JavaScript is because JavaScript only has one thread. It's only got sort of like one pair of hands that are doing work. And if you were to lock up that one thread waiting for data, then it would basically cause the page to become unresponsive because the page can't process other events that are going on in the background. So because of this like single threaded nature, there being like one sort of person or one sort of code pointer going through the code, you can't like block that code pointer just like going around in a loop over and over and over. So the way that this is handled in JavaScript and in other languages is instead of going around over and over and over in a loop like this, instead you somehow tell the thing that it should call you once it's done. Okay, I made a bit of a leap there, but the difference being with this code, when you're down here, it would be like, yay, we received a response. Like, you've gotten the response back at this point, and you can do all the rest of the stuff you'd like with the response. The alternative to this, so this is try 1 here for 4. The alternative to this is instead of like looping around over and over, you could do something like, say, write some code that says like, hey, connection, like when you receive data from the server, let me know later. Like don't just loop around and check. Like instead of me, the person who's wanting to know when the response comes back, instead of that code having to check constantly for when the data has come back, instead, why doesn't the connection just tell you when the data comes back? So in the kid in the back seat bugging their parents analogy, it'd be like the first example here is like the kid asking the parent every second, are we there yet? Are we there yet? The second example here is like the parent telling the kid when they've gotten there. And in general, this sort of pattern of like the person, the thing that is going to know when the state of it changes, like the person who knows when the request comes back, telling everyone else who wants to know, is a lot more of like an efficient pattern. Because imagine you have like a bunch of people that are all asking like this one parent, are we there yet? Are we there yet? Like that's a lot of sort of queries for that one parent to handle. It would be a lot better if that parent could just be like, hey, all the kids who want to know when we're here, like, let me know that you want to know when we're here, and I'll just tell you when we get here. And that's kind of what you're doing. Like you're saying, we're going to somehow say to the connection, the parent in this analogy, what the heck, Doc? Sorry, this thing popped up and it's bugging me. But it's like it would be much better if the parent could notify all the kids. And that's kind of what we're doing here. Where if the connection is the parent in this example, and our code here is like one of the kids who wants to know when we arrive at this location, the way we can tell the parent to let us know is to give the parent some code of ours to run when we get there. And that's kind of the idea behind a callback, where instead of you asking the parent and bugging the parent, are you bugging the server? Instead of you bugging the server, you're now waiting for data to come back, and the server is going to call you and tell you that the data has come back. And syntax-wise, the way you do that typically is you would define a function, like we'll say like data has come back from the server or something. Let's say the data that we get back is going to be here, and we can do whatever we want with it. And in here is where that yay, we have received a response, that sort of logically would go. And then now we would do something like connection dot when response comes back, and then we give it this function. These names maybe aren't so great. I'm just kind of making this stuff up on the fly. But now this is a function here that exists on this connection thing. And we've given it this callback. And we've said, when the response comes back, call this code, and then we get this, then we'll run whatever is inside of the function. Now, the really nice thing about this pattern is while we've run this and we've given the parent this function to run, after that, we can still run whatever code we want. So we could run down here, like maybe we want to make like another request. We could do that here. We could make another request. You could log something into the screen. You could do whatever you want. And because you're not stuck in this loop, that's what it gives you, that flexibility. A term you'll use for this concept is what's called an event-driven system. So this is what's often referred to as like a polling-driven system, because you're polling, you're asking the parent when you get there. The event-driven system is where you basically, this is an event when the response comes back, is like a thing happens, and you subscribe, what they say, to these events. So when the response comes back, your code gets called, something happens. And you can subscribe to, if you have like multiple requests, you can subscribe to multiple of these events if you want. Okay, I just talked for a while. Does that make sense? How am I doing? Cool. It's good to hear that that's helping. And the multiple events run asynchronously. Yeah, so the nature of the asynchronous nature is coming from that they can both run at the same time asynchronously. Yeah. Sorry, I'm just trying to think of a good way to answer your question, because it's yes, multiple events can run at this. Multiple events can be in flight and can be ready to be processed at the same time. I think that's what you're looking for. Yes, great call. I should post this in the code channel. Kind of like being on deck in baseball. Yeah, sort of. I mean, I think actually that analogy might work better for promises. But you're on the right track. So okay, this is kind of the nature of asynchronous things. Let me just run through one actual real API just to show you like this callback in practice, and then let's talk about promises. So in practice, wait, new, there we go. SetTimeout. You guys keep running into this and having some confusion with it, I think, because typically when it's been used, I think so far it's been kind of in a contrived scenario. It is a really useful function, and it gets used all the time in web development. It's just I think these contrived scenarios have made it a bit hard to understand where it would be used. But in practice, this sort of asynchronous nature is true for SetTimeout too. I mean, think about it. You want to say, I want to run some code in some amount of time. Like I want to run this function in a second. Well, what you're doing is you basically like you're telling the JavaScript runtime, in a second, call my code, please. So like it kind of starts to make the "are we there yet" analogy a bit harder to grasp, but it's effectively like you're when you call the function, you're saying how long the trip should be, but you don't want to actually have to pester the parent to know when you get there. So you're saying, if you say like set timeout function for a second, you're saying the trip should take a second long, but I don't want to have to pester the parent, so just call this function once you get there. But it's effectively the same sort of idea. So this function is going to be the event. It's going to get called once that 1 second timeout has elapsed. And to give an example of like where this would be used in real life, let's say you wanted to make an animation. You wanted to make a thing where like you have a box and it starts on one side of the screen. Maybe it like moves to the middle of the screen and then moves to the other side of the screen. And you want to wait like a certain amount of time between doing that. In like other programming languages, you might do that by doing something like MoveBox left. I mean, this is a function. I'm assuming someone's written a function called MoveBox that could take left, middle, or right to where the box should go. But you'd have whatever code you would do to move the box, and maybe like you'd wait for like a second, and then you'd move the box to the middle, and then you'd wait a second, and then you move the box to the right or something like that. And this is the sort of like synchronous way you would do it. The problem is, remember, in JavaScript, you can't really like sleep. You can't block for some amount of time. You always have to keep that thread available so it can handle events that are coming up. So this is sort of like the synchronous way. And this is how other programming languages would do it. But then there's the asynchronous way. So asynchronously, the way you do this is something like SetTimeout. So you'd move the box to the left side of the screen. Then you'd say, set a timeout for 1,000 milliseconds, 1 second, and then call this function after that amount of time has elapsed. And then after it's elapsed, then you would move the box to the middle. Now, once you've moved the box to the middle, you want to wait another 1,000 milliseconds, another second, and then you want to move the box to the right. So you'd put another set timeout inside. Realizing I don't have syntax highlighting on, I probably should. You set another set timeout inside, and then you put right inside of there. So this definitely reads a lot easier than this. And that's like one big thing that will always come up. Like this is a lot more of a complicated thing to understand, just like looking through it. But hopefully you can at least now like read through this and follow this step by step. Like this function's going to run. Set timeout is going to schedule in a second for this function to run. That function's going to run, and then it's going to call MoveBox middle. And then set timeout is going to run, and it's going to schedule this function to run in a second. And that's going to call MoveBox right, and then it's going to be done. The thing that's counterintuitive about all this, and the same thing with this example over here, is like any code you have down here is going to run before any code in here. Because this function is being run in the future. It's responding to an event, something that's happening later on. And therefore, it means what's down here is not in this function, so it's going to run immediately. Like how the JavaScript runtime sees this is more like this, where it sees like, this is a function call, this is a function call, this is a function call, or this is some code to run. And it's not really worrying about what's in this function until later on, until that second has elapsed. So I bring it up just because this is something that a lot of people find counterintuitive and get jammed up on, where code after this is going to run before this. That's the same thing with our example over here. Like this here, if I have code here, this code's going to run before this. Does that make sense? Cool, I'm seeing some shaking heads. Okay. Also, like, if you don't get this, I know I keep saying this, but this is just something where you have to be exposed to it over and over and over. And like, you'll slowly start to figure it out. Like, repetition is key here. This sort of asynchronous way of writing code is confusing, but has some real benefits. It's just sort of unfortunate JavaScript forces you into it kind of right off the bat. This is something that ideally I'd much rather teach once one's really gotten comfortable with the way of writing synchronously, but you just kind of have to get into this right away with JavaScript. Okay, let's talk about promises. So what's the difference? What's the difference with a promise and a callback? Like, I keep maybe bringing up that they do similar things and that a promise is like all these things in the JavaScript libraries use promises. What's the deal? Well, a promise is effectively a different sort of way of representing the same callback event-driven behavior, where an event occurs or something starts, then later on an event occurs, and then the code is run that's in a callback function. Yes, thank you, Kelly, for reminding me.
Actually, you need to change one line there. On line 10, it says other programming languages. You should change that to JavaScript before you post that.
Oh, no, this is correct. So other programming languages might do it this way.
Yeah, but the lower down one that has JavaScript.
Oh, this one.
Yeah.
Okay. I'll actually just get rid of this whole line. Or I'll say JavaScript does it this way. Actually, I'm going to put a comment in front of this because people are going to get confused. Okay. So, here's the problem with callbacks. This will probably seem a little bit like a review from Thursday, but I want to go through it again now with your newfound knowledge of callbacks. You started to see it over here, where this code, it's like very nice. Everything is very linear, very easy to read. This, though, you can see how it starts to get like, you start to have to indent a lot. In fact, this can kind of end up being taken to the extreme, and you can start to kind of go further right sometimes than you actually go down. If you have to do like a number of asynchronous operations in a row that have to happen in sequence. And this concept is called callback hell, and it is a real thing. It's a problem that I think it's worth running into like on your own, because you'll start to see kind of how frustrating it is when you have to go to the right like so much to read a lot of the stuff, and it makes it really hard to reason about the order of things sometimes, or like to think about them in that way, because this is very intuitive. This is not intuitive unless you spent like years parsing through this and understanding it. So promises were sort of invented to try to make this be a little bit more like this. But of course, you can't just got lost in the code weeds. Where'd you get lost, Carolyn? If you got lost, probably some other folks got lost too.
I'm saying when you're talking about how it basically gets disorienting and everything.
Yeah.
So it's kind of, you get lost in the code weeds in the process. No, I'm with you.
Okay, cool.
Thank you.
So how, of course, like you can't just write this in this way. Like if you tried to try to do something like this, like that's not going to work. Like there's no way in JavaScript to write it exactly like this. Like you have to somehow have these callback functions in there somewhere. So how do you do it? Well, kind of the first sort of revelation that people had is it would be really nice if the return values of functions could mean something again. And what I mean by that is like SetTimeout, the return value of SetTimeout really doesn't matter all that much. Like the code that's going to be running based on the result of it, or maybe a better example is like our request over here, where the data is not being returned back to by a function. It's being passed as a parameter to the callback. And because it's being passed as a parameter to the callback, it means that you're stuck inside of this function. Like you can never get this value back out into the parent context again. And that's because you're doing that, that's really the source of all these indentations. Yeah, Carolyn, I didn't address this. Carolyn asked, sleep is used for synchronous and SetTimeout is used for asynchronous. Sleep is a function in a lot of other programming languages. It just kind of means halt for some amount of time. for example, if any of you end up touching Python, they have a function called sleep that basically looks exactly like this. Sleep's just kind of the standard name for it. I should have called that out. Yeah, sleep means wait. You'll also maybe see like delay as like a name for it. You'll see it occasionally. Yeah. So because this data parameter is in this function here, that's where that indentation is coming from. Like you can't, that's kind of the source of the problem. So wouldn't it be really great if you could somehow rewrite this? You could somehow rewrite that to look like this. Like that's really what we want to be able to do. But we just can't really do that. So we can't do that. So there's going to have to be a callback in here somewhere. But we want to make that return value mean something. So what if instead we sort of made like the return value have two possible values? Like, stick with me here for a second. If we made the return value sort of like be like empty, and then eventually later on be able to be like filled with data. So imagine like in this example, we get back to our thing like this. Imagine like that data somehow like starts as null. So like data is null. And then like some time goes by. And then maybe you log out data again. And now like it's some response data. So this doesn't fully solve this problem, but at least now we've got this data like outside of the function. So that at least solves like the indentation part of it, but it doesn't really solve like the I want to run code when data gets filled with information part. And we're kind of then we're stuck back into this sort of situation where like we have to keep like we have to like basically say while data is equal to null, like just like spin around and just kind of wait and wait and wait and wait. And as we said before, this is not going to work. JavaScript's not going to like this. You've got to keep that thread available, that main thread available so you can do work. So what can you do? Well, this is a really powerful idea. So what if you could extend this and kind of basically like do this, but not on the actual operation itself, but like on this value, like do something kind of like be able to say like data that like once this is not empty, then like call a function. Or something like that. And you might think like, well, this kind of gets our indentation problem back again. And you're right, it does. But it's sort of, we can sort of deal with it. If we don't care about what's actually inside of data, we only care that like data is a thing we can use in the parent context. For example, like let's say you need to make like a bunch of these requests. Like data 2 and data 3 now exist. You can sort of treat data 2 and data 3 as sort of like opaque containers that you know this will eventually be filled with data, but I don't really care about that data yet. I just want to have like a handle to that request I can keep around in memory, and I can like store in an array, and like I can loop through. But once I actually want to know what's inside of that data, that's when I have to use the callback and get into it. So it means instead of having to have like multiple indentation levels, you still have to have one for the callback at the end, but you only have to have one at the very end, not like them throughout the code. And this is not a perfect situation. You definitely still end up needing more callbacks than you'd like, but this at least makes the problem less of a problem. And you probably can guess from where I'm going here. The real name for this is then. So the other thing I want to bring up that to make this actually work in a actual code that would work is data is not actually the value of the thing. If you remember from JavaScript, JavaScript has what are called reference types and value types. And primitives like nulls and strings, those are value types. So if you return like a string from a function and then you modify that like value later on in the function, it's not going to actually update the thing that's been returned from that function. It's passed by value outside of the function. So you need to somehow have, if you want to be able to update this from inside of this thing, this has to be a reference type to let you do that. So like maybe a sort of hacky way you could do that is you could maybe have like an object with like a key of value. And just this would allow you to mutate this later on from within this context. It just turns out that this sort of thing, there is a built-in version of this called a promise, uppercase P promise. So that's what that's about. The uppercase P promise is like the way by which you can make one of these things. And there's no reason you couldn't like invent your own promise if you wanted to. Like you could make an object with a key of value that maps to null or that like gets set to a string. That would work. It's just that uppercase P promise implements the whole logic to make then work and makes all the other promise stuff work. So that's kind of why people use promises and don't try to roll their own usually. So promises are a big topic. I just have covered like the very high level theory here. How are you folks doing? I'm guessing it seems like you're doing a little bit better than last time. Can you give me some yeses and nos in the chat? Okay. Better is we're headed in the right direction. So that's good. I'm going to bring up one more thing. I didn't talk about this before, but I went into this whole callback health thing. I want to close a loop and explain sort of part of why promises can really help solve that. Whenever you use this .then, it actually returns another promise. So I'm going to make a copy of this. I don't want to put it at the bottom here. So let's say we have our fictional data, which is a promise of some sort, or yeah, promise of some sort. And we do something with it. So it eventually data is generated, and then eventually once that data, that value goes from null to being filled with something, this callback function gets called. And you can do whatever you want in here. But the cool thing is this actually returns another promise. And whatever you return from this, let's say I just return like 1, 2, 3. Now data 2 is a promise that contains whatever you return from this. Why is that cool? Well, it means code that used to have to look like this now can look, well, let me copy this over here. And this is like when I learned this was like the big game changer to me on why I thought promises were so neat. Code that looks like this can now look like this. Or actually, sorry, not MoveBox. I really want like, let's invent a fictional function called delay that when you run it, it will wait for some amount of time and return a promise that will resolve. It'll call then after that amount of time. That's going to be basically a promised version of SetTimeout. So I'm going to say like delay 1000, promise 1, not then. This is going to run after a second. I'm going to call MoveBox middle. And then here's the real trick. I can go promise 2 And then here, go promise2 dot then MoveBox right. So what's cool is this went from 2 indentation levels down to 1. And the reason why this works is promise 1, it's going to do whatever it's going to do from here. And then it's going to resolve, and it's going to put that value into promise 2, and then it's going to sort of chain down to the next one. So this isn't going to resolve until this runs and the dot then code runs. And once it does, it's going to cause this to resolve, which is going to cause the next one here to resolve and kick it over. And basically what you end up doing here, when JavaScript runs through this for the first time, it'll run this synchronously, sure. Oh, actually, I need another delay in here. Oops, sorry. Well, let me talk about this in the lab, the other delay. But what'll happen is JavaScript will run this. It will run this, and then it will set this up. It'll like say, okay, once this delay is completed, call this function. And then, but it'll return, that whole thing will just return like an empty promise that hasn't actually resolved yet. And then you then attach an event to this empty promise to call this function once that's resolved. So you sort of are like setting up a bunch of dominoes. And then once this first promise resolves, it causes like every domino to cascade down and cause every function on each then to run. It's really, really powerful because this is a heck of a lot easier to read, in my opinion, than this, if you write it well. There are even better ways to write this stuff, but I don't want to talk about that quite yet, because that's gonna be a big thing. Let me add this delay in here. So I'm gonna get rid of promise 2, just because that's actually how you tend to write this. You write it like this. But in effect, it's the exact sort of thing, same thing. So what you do is you stick a then in here, and then you'd delay 1000. Oh, oops. So the reason why I mentioned you can return things from here, I'm returning a promise from here, but it's able to understand that's a promise. And it's not like a promise within a promise. It's just one level of promise. So whatever you return from here, it can either be a promise or it can be a regular value, and it'll treat them interchangeably. So anyway, this is how a lot of this async stuff gets done these days in the browser, through using promises, chaining thens together in order. Yeah, Carolyn. So what this is doing is this code and this code do the exact same thing. So I'm assuming this fictional delay function exists that waits a certain amount of time and returns a promise, and after this amount of time, that promise will resolve and it'll call the dot then. Assuming that function exists, it's going to do the same thing. It's going to move the box to the left. It's going to wait 1,000 milliseconds. It's going to move the box to the middle. It's going to wait 1,000 milliseconds. It's going to move the box to the right. So left, middle, right, with a second in between each movement. It's going to do the exact same thing. It's going to be on the left. Delay is going to be invoked, which is going to return a promise that's going to resolve in 1,000 milliseconds. That promise is going to resolve, and when it does, the dot then is going to be called, which is going to call this function, which is going to call MoveBox middle. And then after this is run, then it's going to call this next then, which is going to call this function, which is going to return the same sort of thing, a promise that waits for 1,000 milliseconds. Yeah, sort of. So Carolyn said, like a when means then. Yeah. It's effectively you're setting up all these dominoes. Like each of these dot thens is a domino that'll run. And actually, in practice, this probably would look like this. It wouldn't have that extra dot then in there. But you set up all these dominoes and you run each thing, and then anything you return from one of these dot thens is available as a parameter in the function below. It isn't a loop. So Carolyn asked, so it's a loop. No, it's not a loop, but it's a way of writing it's a way of managing the asynchronous tasks. It's a way of running a bunch of things asynchronously, but being able to write large parts of them synchronous together. So effectively every .then, kind of like above where we had like our wait step up here, like all this up here is synchronous. This is the asynchronous part. And then everything below it is also synchronous. So it's like if you could somehow make that wait step synchronous, you could write the whole thing synchronously. Yeah, like a shorthand. So what this is doing is it lets you write everything you want synchronously. And then when you need to do something asynchronously, you then can utilize this sort of then infrastructure, and you return the asynchronous thing. And once the asynchronous thing has completed, then it'll call the next .then, and it'll trigger the next set of synchronous steps that have to happen. Again, if you don't get this, that's totally fine. I just know there are some folks that are getting this, and I wanted to give them the next step so they kind of know where to go next. Is .then used in any other JavaScript context? No, .then is really a promise-specific thing. So .then is a method on promises. Just like, I don't know, like index of is a method on arrays, or like, I don't know if that means anything to you folks yet, but cool, okay. Yeah, so .then is like a promise thing. Yeah, so when I was, the simplest use of promises, kind of stepping back from all this, like kind of back up to the stuff that is not maybe a stretch for some of you folks. The simplest use of promises kind of looks a lot like a callback. So you have like my function that returns a promise. And then instead of putting the callback in here, you just sort of instead get the return value. You call then on it, and you put the callback there instead. So if you're still having sort of difficulty with promises itself, you can think of it in this sort of way, where you're just moving the callback to a different place. And for the simplest use of promises, that's a good way of thinking about it. And for everything in this module, you're never going to have to put multiple thens in an order, or you're not going to have to worry about multiple promises. You're only going to have, like for this module, this is as far as you're going to have to go. Okay. I spent most of the time just talking about promises. How do people think? Are doing better, I think?
Yeah, definitely much better. It's probably just the nature of learning this stuff if you don't really have a strong programming background, but also I think they're going to redo the module in the future, because the whole way it was initially presented was like, and it's like, if we had started this way, so thank you so much you're fantastic. Thank you.
No problem. I'm glad that was
helpful. I'm actually starting to really like JavaScript. Don't shoot me. It's actually kind of fun once you like get in the mindset of it. It's like a culture.
Yeah, definitely. Kelly's reminding me I got to put this code in the chat. I'm sorry. Okay, this is the callback style, and this is promise style. Okay, there's one last thing I want to say, just so that you're aware this third method exists. I think Max briefly mentioned this to you, async await. He talked about that. I'm not going to go into it. It's really, really cool, but like, I don't think it's going to be, I think it's just going to only be more confusing right now. So I'm going to put down here async await sometime in the future. I just want to call out there is another way to do this. Okay.
I just have a question about the promise style, the middle one there. You said something toward the end that confused me a little bit. You said that it would be available as a parameter in the not then below it, but there's no parameter in that function.
Yeah, good point. So I don't know if you've actually talked about this, but in JavaScript, the number of parameters a function has and the number of arguments used when calling the function actually can be different. Let me actually go into Chrome for this. So let's say I've got good old add A, B, return A plus B. And if I call add like this, you'd think this would throw an error, like there's not a B, but it actually works. And the reason why it works, well, let me log out A and B so you can see what they're equal to. So you see A got populated with 1, but B is undefined. If you talk about undefined, undefined, does that ring a bell? I imagine you've talked about null. Okay, so in JavaScript, there's like two sort of values that mean something is not set. Well, actually, there's 3, but we're only going to talk about 2 right now. Well, actually, we're going to talk about the third, NaN. Yeah, okay. So I guess we're talking about all 3. So there is null, there is undefined, and there is NaN. Conceptually, they all sort of mean the same thing. A value that, like a not complete value. So typically, if you have like a thing where you want it to be equal to a value or you want it to be unset, you'll typically make it, it's called nullable. It can either be like a number or it can be set to null. And sort of that sort of bi-state nature of it allows you to represent both those cases. Null is what exists in most programming languages. It's what most people are familiar with. Undefined is sort of a weird JavaScript thing. And the biggest place you'll see undefined is if you have an object, like let's say something like that, and you try to access a key that doesn't exist. You get undefined. In general, you'll see undefined in JavaScript anywhere there's a value that is it's not being set by JavaScript internally, or it can't be found by JavaScript internally, or yeah, it can't be found by JavaScript internally. That's probably a better way of saying it. So for example, with this this function call, that B didn't exist, so JavaScript just said, oh, that's going to be equal to undefined. In this case, that key couldn't be found in that object, so it just says, oh, well, it's going to be equal to undefined. And it tends to be that undefined is a value that's used a lot more by the JavaScript runtime and less by programmers intentionally as like a thing they add to their code. That's not a hard and fast rule. Some people will use it in certain places, but in general, null is usually the thing people jump for when they want like a value that means like an unset value. You'll run into both of them though. So you can treat them, for all intents and purposes, though, as the same. NaN, it's a bit special. So the one place that you'll see NaN that's important to know, if you're talking about parse float or parse int.
Yes, we use that for actually the async example, I think. Not the async, the callback hell example. I haven't gotten as far as, I've been reviewing through Max's video somewhat, but I haven't gotten past the callback section yet, but I know he used it there.
Okay, so basically parse float is a function built into JavaScript, similar to like SetTimeout and those things that are built in like global. Like if I run parse float, you can see it's one of those native code situations. Parse float is a function that takes a string that contains a number and it returns the number inside of it. So like if well, you saw that my 4.5 example there, but let's say I give it a value that's like not a number, like it's some sort of like weird value, like maybe hello. It's going to give me back this weird like NaN thing. And notice this isn't like NaN in quotes. It's like a value. It's like NaN. NaN stands for not a number. Seriously, someone like came up with that. And it is a numeric value in JavaScript that refers to a number that is not numerical. So if I like do type of NaN, it's number. Like, but NaN stands for not a number, which is a little bit funny. The reason why I bring up NaN too, and those are like the 3 values. Like, I don't think there are any more like null-esque values you need to worry about. But
null and undefined are types, right? That NaN is the only one that's not a type.
Yeah. If you go like type of undefined, that is, the type is literally undefined. If you do type of null, I should know this off the top of my head. Yeah, null is object. Okay. Yeah, null is a little.
I remember those two from like the very, very beginning of the JavaScript module. That, yeah, and I didn't remember that it was, maybe type is the wrong word, but Gaus was talking about different like really basic things, and he was like, it could be a string, it could be a number, and undefined and null I thought were like equivalent to those.
Yeah, it is. That's a good way of thinking about it. And for all intents and purposes, you can think of this as just saying null. Like, they're explicitly they're values that mean nothing is assigned to this, and they're usually used in concert with other types. So you typically wouldn't have a variable that is only of type null. It would typically be a variable that maybe is type of number or can be type of null. And like it's usually like you see null or undefined or NaN, they're used more as like it can be a type of X or it can be one of those values. So going back up to our add example, let me get that back up here. Okay, so add A, B. Oh, I gotta actually give them actual values, don't I? So that works. But this gives us NaN. Why does it give us NaN? Well, JavaScript has some really fun ways when you add things together that aren't numbers, how it reacts. I could spend literally hours talking about all the idiosyncrasies. I'm not going to, but what I'm going to say is, if I do 1 plus undefined, I get NaN. So that's where that's coming from. It's adding the NaN, which is why. So anyway, the whole point I'm trying to get at here is you can call a function in JavaScript and not give it all its parameters. Similarly, in JavaScript, you can call a function and give it more parameters, and it'll just ignore those extra parameters. So in other words, the number of parameters you pass to a function in JavaScript and the number of arguments it expects, they're not one-to-one. They can be different. Sometimes they can be ignored if you have too many. Sometimes things will be set to undefined if you don't set them. So if the number of arguments in a function really, really matters, you really have to just check. You have to check to make sure everything that has been passed is not undefined explicitly, and like throw an error or like scream loudly to the user that that's a problem, and they have to fix it. This is not a problem that happens in other programming languages. Other programming languages are much more sane. Let's put it that way. So Carolyn asked, why does this last example not add 1, 2, and 3? Good question. Well, the reason why is A and B are the only 2 parameters of this function. So if I'm giving it a third parameter, I have like no C here or no other value. So because I've got no other value there, it's only going to add those first 2. It's only going to add A and B. But you're right that if I did something like this, I put a C here, like that is going to add them all because now I have that extra parameter. So where was I going with this? I kind of went off on a big tangent. I guess that's sort of what I do. But
I was asking, you said that the promise, promise 1 creates another promise that gets passed as a parameter in the last .then function in that function, and there wasn't a parameter in the parentheses.
Yeah,
I'm a little confused with that.
So the deal that's going on there is I could put a parameter here, and technically the signature of .then expects you to put a parameter there, but I'm not going to use it anywhere in the function. And if it's a promise that like when it resolves, it doesn't have like an important value in it. Like this delay thing's fictional, so I guess it could be whatever. But typically, like if you have a promise where the actual like what matters is the promise resolving and not the data the promise contains when it resolves. Usually, if that happens, you just will like kind of put some bogus value in there. Like it might be a promise where it resolves and the value inside of it might be null. Like that happens. If that matters, or if that's what's going on, you don't really have to put this here because behind the scenes, the promise library is going to call this function and it's going to give it that parameter that's inside of the promise. But like you don't need it, so you can just omit it, and it's still going to work because the number of arguments to that function aren't going to be a big deal. So does that answer your question?
I think so. Yeah, I'm used to passing parameters in a much more obvious way because it's not even showing that it's passing it. There's no place there that it's you're calling the function with and putting the parameter. Yeah, so it's just a little confusing to me, but
yeah,
okay. I'll watch this again. I'm sure this is the type of video that I'm going to go back and watch several times, like especially as we learn more and I understand this better. Yeah.
So
it's helpful.
It's important to point out that with callbacks, you often don't get to see what's calling your callback. That's usually something in the code, like in a library somewhere. So the way you kind of figure out the parameters being passed to this is usually either through digging around that library code, if you're unlucky, or if you're lucky, there's documentation and you just can follow what the documentation says. Like if the documentation says that this is a promise that contains like, I don't know, like a random number, and I want to get access to that random number, then I might just know, okay, well, I'll put a parameter here, and then now I can use that in here somewhere. So Carolyn asked, is a typical delay 1 second? No, it's just kind of a number I made up. This could be whatever you want. It really depends on the sort of, I mean, if you were doing this actually in real life, you probably would have, you would start to tweak these numbers to make it kind of look pleasing or appealing to perform the sort of animation you want to do.
Or seamless to the user. They don't know.
Yeah.
Also, the question before that, when we were talking about my, kind of added on to my question about why it didn't go ahead and add the 1 2 3. I mean, normally I would have understood that, given that the parameter was A, B. But then I heard you say something about one-to-one correspondence between parameters, and I got to thinking, oh, you can just, I got confused by that.
Yeah, okay. So
in which case it would have added the 3, but I'm obviously not understanding it.
Well, the kind of the thing that's worth pointing out is if you have extra variables in here, if you have extra variables when you call add, and you only have 2 parameters here, it's just going to kind of throw away that last parameter. Like it's going to use, this is going to become A. It's going to go like 1 by 1. It's going to look at the first parameter. That's going to become the first thing. It's going to look at the second parameter. That's going to become the second thing. And if there's anything left, it's just going to kind of throw it away. If there's not enough values, it's going to set all the rest of these to undefined. So like if this was like C, D, E, F, and we go through that same exercise, it's going to set this to this, this to this, this to this, and then it's run out of values here. So it's going to say, okay, this, this, and this, those are all undefined.
Okay. But you said something about there not being a one-to-one correspondence. So I think maybe I have to look at it going in the other direction. That's where I got confused.
What I meant by that is when you call add, you don't necessarily have to give it 2 parameters. The parameters here don't have to match up with the parameters you're calling it with.
Whichever, okay, but you have to make sure you have enough in the first one if you are going to, so if you were to call a D in this case, it ain't there in the function parameter. Okay, I get it now. Thank you.
Okay.
I just was like thinking, see, I'm still thinking top to bottom, left to right, and it doesn't work that way.
Yeah, in the real world, it doesn't work that way.
The JavaScript is done. Thank you.
Yep. So I kind of did a bunch of stuff on promises here. I didn't talk about any sort of HTTP, Ajax. I probably keep using that word Ajax, but I never have actually defined it. I should do that. Ajax stands for, oh gosh, Asynchronous JavaScript and XML, I think. It's a terrible acronym. It doesn't mean that at all. What Ajax means, you'll hear the term Ajax request or Ajax. When you hear that, it means making HTTP requests in JavaScript in the web browser. The reason why they call it that is because so the browser will make requests on its own. It used to be that Ajax requests were like kind of special. Like what you would do is you'd make a web page and then you'd be like, oh, I'll just throw in this little request in JavaScript to like make it work. Later on, like at the very end, like maybe I want to make a request to a server and I want to get some data and I want to show it somewhere. And that was kind of like the exception to the rule. So like it was like, yeah, we're going to use this new fancy Ajax technology. We're going to use it to populate this little value. Over time, it's become the fact that like the majority of data shown on the web is requested via HTTP on the web. So much so, like kind of the term has fallen out of favor. Where it used to be like, yeah, we're using the spiffy new Ajax technology. Now it's sort of like, yeah, everyone is. You don't need to really call it something special. It's just like you're making an HTTP request. So if you hear me say that, it means the exact same thing as making an HTTP request on a web page. I think that's right, Kelly. I'm not 100%. You might have looked it up.
I looked it up. It is.
Okay. Nice, I got it right. Yeah. So sorry, another distraction there. But does anybody have any questions about HTTP or making requests with Axios or anything like that they'd like me to go over? I'm assuming most of the questions around that were related to callbacks and promises and all that.
I have a question.
Yeah.
I honestly couldn't get just the basics to work on mine. So I'm not sure what I did or what I'm missing, but is it okay if I share my screen for a moment?
Yeah, go for it.
Okay, this is Shantina, by the way. I'm sorry.
Hey.
Hello. All right, am I sharing? Yes.
Yep.
Okay. Well, that's not what I had. I had it already. Oh, here it is. When this is just from when we were working on this, this is what I was getting and I couldn't get past. This is like my umpteenth attempt at trying to get the correct response.
Yeah, you are so close.
Do you see it already?
Yep. So take a look at the error you got.
I'm sorry, can that be blown up just a little? Even on my big monitor, I cannot really see it well enough to see what's happening.
Do I have to blow it up or can you blow it up?
If you hit a Command plus, it'll make it a little bit bigger.
Okay, because I wasn't sure how to do it.
Yeah, sometimes with Zoom, it doesn't. Okay, thank you very much.
You're welcome.
I want to kind of see what.
Okay,
Oh.
so
Okay.
take a look at the error message. It says type error, console.lo is not a function.
Oh my geez. Is that supposed to be, that's log?
Make the correction you think you got to make. I think you're on the right track.
I've stared at this. So it was the typo right here.
Yep.
I've looked at this for hours. Thank you.
No problem.
The nature of the beast, I'm afraid. I can't believe how many little things I'm catching myself as I'm typing sometimes, but it's like it throws everything off. And that's why, like Max was telling me, you got to do the errors as they happen and not try to fix them all in the end because you'll never know. Yeah, we're all
just saying it out loud sometimes too.
Yeah, me too.
And I just kept reading that as if
You
that's
saw
something
the
that
G.
we've been doing all this
Your
time.
brain put the G there. Yeah, that's very typical. Yep, you got it.
Yeah, by the way, what Max said, that's totally right. And when you do wait till the end to debug something or like to run your code, be ready for like hours of just banging your head against the wall. Like it's much better to write small pieces in isolation and test them and then join them all together than try to write one massive thing.
Right. Thanks again.
Yep.
I'll go do my work now.
No problem. Anybody else have anything they'd like me to go over?
Yeah, for the weekend thing, I haven't really looked at it, or I was working on some catch up yesterday. So today I'm going to work on that. And I know there was something you had posted about something that wasn't working because of something else or whatever.
Yeah.
What will I probably encounter? What should I be aware of? Like I said, I haven't even really looked at what you need us to actually do for that part.
Yeah. So I'll be honest, like the weekend assignment is basically exercise 1, but put it in an HTML page. So if you can make a request with Axios, you can do the .then on the promise you get back after it. You can attach the callback. You can log some data out when when the request finishes. You can put that in a web page. That's the weekend project. So
yeah, and when we one of the other exercises we were doing, I think it was with Axios, you talked about putting the request in the browser, and I wasn't sure where, like I put it up where you type the URL in. Mm-hmm. And I didn't know if it tagged on to almost like a path to your server, or if it was like the server space. And then I wasn't quite sure where we were doing that, if there's something in the not the console, but the dev tool thing that I didn't understand because I haven't used that part of the HTML part before.
Yeah, I mean, any request you're making to Axios, you're going to want to do in JavaScript, not up here in the URL bar. You're going to want to do that in.
So you want to be in that console. Okay.
Yep, in the console.
So you're still, but if you're making the request to that URL, then we follow all the different things we've been learning, except we use the Axios syntax.
Yep.
Like we did with NC, and you see, these things are so obvious. And I'm like, okay, I do speak English sometimes. Thank you.
No problem. So the one thing that the thing that I posted about this morning is I had thought you folks had learned how to add DOM elements to the web page, but that apparently is not something you've learned. That last part of that assignment, what I had basically asked you to do is dynamically create an HTML element with the contents of the data you get back from the server. And I think you kind of have done this a little bit. Like, does the get element by ID function sound familiar? Does that seem like something you've done?
Yes.
Okay. So one thing you can do, you can, if you make a new div on your page, and this is, by the way, like, if you aren't able to figure this out, really the important thing for the weekend assignment, the weekend project, is that you can log out whatever you get from the get back from the server. But in addition, if you're able to do that fine and you kind of want like a next step, this is what I'd say do. Create a div on your web page, give it an ID of something, whatever you want, and then do something like, let me share my screen here. And go back to the lesson when Max was talking about this for more about the actual like syntax and what's going on. But something sort of like document.get element by ID, my ID, dot inner HTML equals thing or whatever you want. And what you want to write to this is something like response dot status, or some data you got back. You would do this inside of the .then, the callback inside of the .then. And by doing this, what I'm trying to show is you can make a request to a server, you can get data back from the server, and then you can take that data and you can write it to the screen and you can show it to a user. And now you're starting to dynamically build a web page based on data that exists in another system. And that is like a really foundational concept to the modern web. So I'll put this in something like ID equals my ID. put this in the student pasted code channel. Again, if you don't want to get that far, you're not able to figure that out, that's fine. Feel free to skip it, but if you want the challenge, give something like that a try. Okay. Anybody else have anything else they'd like me to go through? Oh, someone asked, do you have time to go over an await example? I can. I think I'm going to put that, though, in the same category as like the chained dot thens, where like you might have trouble with it. And if you do, it's fine. You'll get there, but don't feel bad if you don't get it. Okay. Let me give this a try. Okay, so actually now, let's where was the thing I had opened up over here? Yeah, this thing. Okay. I'm going to bring these two examples back over here just because this is a place we can start. So remember, synchronous, this is the easiest to understand. This is like how we really would like to be able to write it in JavaScript. Asynchronous, this is the way we kind of have to, by necessity, write it in JavaScript. And then, actually, wait, I already have this above. What am I doing? Okay. I'm making a real mess of this file. So we've got our callback style, and then we have our promise style. So this is where we're able to chain with .thens and sort of, now we only have one level of indentation. That's really nice. But, and this is how software developers think. They're like, I really would like to have 0. And there's got to be a way to make this actually, oh, I don't have the synchronous example here. But there's got to be a way to make that exactly like the synchronous example. Like, this just is so pretty and nice to look at and easy to understand. It would be really, really great if the asynchronous thing could work in this pattern. And it turned out that someone, I think at Microsoft, had this like really good idea to sort of flatten out these promises. And they originally introduced this concept called async await into C#, and then a bunch of languages copied them. So what does this mean? Well, let's start with our promise style, and we'll kind of try to slowly adapt it to be into async await. So first up, I said we want 0 indentation. So in order to do that, we have to get rid of these functions. Like, just by nature, that's going to have to be what's going to happen. So we got to get rid of our functions. And I'm going to just add a little white space to make this a little easier to understand. And then we then have to get to everything's back at the base indentation level again. Very good. However, these .thens, this isn't valid JavaScript syntax. Like, there needs to be a function in here. Like, you can't put code just inside of a function call like this. So we have to get rid of our .thens. Like, that syntax isn't going to work anymore. Okay. But now we're kind of in a pickle because this isn't going to work either. Like, we're running all this code immediately. Like, there's nothing to say like delay, like nothing to actually delay the code. No sort of callback to run once the delay has completed. So we need some sort of other trick. And really, like, what we want to be able to do is something like have this delay, like assign it to a value somehow, or like we want it to be synchronous. We want it to be like the synchronous example. So what if we introduced this new thing in the JavaScript called await? And if I put await before a function call that returns a promise, the special thing in JavaScript, the special await, is basically going to say everything after this line in the whole file act like it's within a callback function. So act like there's a function here that all this stuff is in. And once this promise resolves, call this function. Now, of course, this function's sort of like implied. It's not something that's actually there in the file. And if it was there in the file, you'd have to indent everything over, and then we're back to the problems we had with .then. What await basically does is it lets you write code synchronously, because the data here you're getting that's being returned is what would be in the function parameter here. And it's what would be, like in the synchronous example, it's what would be returned from like MoveBox or from any of these functions to their return value. So it sort of lets you treat things that are promises or that return promises. It lets you treat them synchronously because this is all one line. But what you trade for that benefit is that the code that's running after this line is kind of a lie. Like, this isn't actually what JavaScript's doing behind the scenes. What JavaScript's doing behind the scenes is actually this sort of thing. And to complete this example, just so it's really how it would work, is like this. It's a lie. Behind the scenes, JavaScript's actually doing this sort of thing. It's actually running code that looks like that. But this isn't going to, like, this doesn't have that nice benefit of synchronous. Like, it's not a synchronous looking thing. This is very synchronous looking. If I gave this to you before this lesson, and I told you to tell me what this does, you probably could walk through this and be like, okay, well, it does this MoveBox left thing. It waits for 1,000 milliseconds. It waits for 1,000 somethings. Moves to the middle, waits for 1,000 somethings. It moves to the right. Like, this is very readable. And that's kind of the benefit of this await syntax. The downside, though, is you'd have a lot less clarity on what's going on at the lower level. One clarification I want to make, too, is that it's running these in order, synchronously, like, not synchronously is a bad word. It's running them, running each of these delays one after another. So this first one's going to run, and then the second one's going to run. It's going to act like synchronous code. Same thing as this, like it's going to run this, then it's going to run this. But like when you work with async and await, and we're going to talk about what async is about in a second. When you work with await in particular, you can basically treat asynchronous operations like they're synchronous. So you can do something like this. Like, that's totally valid and is so nice. Like, there's no .then involved here. You're basically just saying, like, call this function, wait for the promise to resolve, and once it's resolved, store whatever it contains into response. So I will say, when I work with async stuff pretty much universally now, this is the format I use. It's just so much nicer. Okay, Carolyn asked a question. So all the function stuff is actually still there, but the code format the developer reads and manipulates is so much more intuitive and manageable. Yeah, exactly. You're exactly right there. It's in fact so much more intuitive and manageable that you don't even think about the callbacks anymore. Like, what I'm explaining to you is just what you need to understand to jump from the .then style to the async await style. But like, you don't think about the functions. Like, you just think about this happening synchronously, and JavaScript just kind of makes it happen synchronously, like kind of behind the scenes, wink, wink, synchronously.
I have a question about that, actually. I don't mean to interrupt if you're, but I don't understand how JavaScript knows when to end its invisible function that's inside. How come the rest of the file just isn't in it?
It is, the rest of the file is in it. Yeah, it's.
So what if you wanted to put something else after that?
You can't. But Also, like, you probably don't have a reason to in actuality. Like, in this sort of case, if you wanted to run something after this promise has run, but before you've actually waited for it to like resolve, the best way you could do that is something like this. And you put your code here. So in actuality, like there's no like similar concept as to where was it? Like there's no similar concept to like code after the then. But the closest you can get to that is running code after you've called the function that returns a promise, but before you wait for the promise to resolve. I would argue, though, if you're writing things where there's an active reason why you need to do something after you've created the promise, but before it's resolved, it might be a sign that you should rethink how you're designing it. In general, having to do things like this is rare. And when it is something I need to do, I usually will have to jump down to the .then syntax because this is just more flexible and allows you to kind of do the sort of crazy nuts things that like occasionally you might have to do. But when I have to do this, I'm always kind of thinking in the back of my head, like, why am I doing this? Is there a better way to be doing this? So, did I answer your question?
I think so. Yeah. It's just about how you arrange the file, I guess. So
yeah. And the important thing to call out here is like the await is similar in concept to the then, where this is where the you're waiting for the promise to resolve, but this is where the promise is being created. And those are two distinct operations. And up here in the .then example, this is where it's created, and then this is where you're waiting for it to be resolved. So they are distinct. It's just you don't necessarily have to think about them as much being distinct in this style. I don't know. Or I think I said that wrong. Anyway, I think you get what I mean. Caroline, I saw you had a question, but I will need to look through it here.
I think you were answering it when my dog started going like bark shit crazy, excuse my French.
Yeah.
So I don't want to lag down the class if you want to send it to me later or whatever, but I really did not catch your answer. Sorry.
The gist of it is you're totally right. You have the exact right idea. Yeah.
For once in this module, not 5, I mean from 4. Yeah, thank you.
Yeah, no problem. Okay, so there's one last thing with async await I got to bring up, and that's what's the deal with this async part. We only talked about the await part. So it turns out that similar to like the .then, there's a sort of problem you'll run into with await, where you'll have code that is synchronous and then code that is asynchronous. You need to somehow like have a bridge so that they can interoperate together. And the way that you end up doing that is by writing functions. So in practice, if I were to run this in the JavaScript console, if let's say delay actually existed and this was real code that would work, it wouldn't work and it would throw an error. And it would basically say something along the lines of, you can't use await outside of an async function. What does that mean? You can't use await outside of an async function. Well, await is it gives your async code synchronous properties. But in order to do that, you have to basically put it inside of a container that says, this is like the special container where async await works. And if you just do it at the root of the file, JavaScript's not going to understand it because your asynchronous code I'm going to kind of dodge the question here because it's a complicated answer, but your asynchronous code can get into a state where it's not the synchronous JavaScript isn't going to be able to really understand it or work well with it. I know that's abstract. Maybe just as a takeaway from that, you can't use a await at the top level, and there's a good reason for it. But the way you would actually use await is you need to put in a function. So we're going to say my fancy async stuff. So that's great. And then I could, let me count that out. I could call my fancy async stuff. Cool. You think that does the exact same thing, but we still have this problem. Like it says await cannot be used outside of an async function. Okay. It's clear we need to figure out what this async function thing means. And an async function is a similar syntax level addition like await is. Like await is a keyword, it's pink. Async is also a keyword. And what an async function is it is a keyword you have to put before a function. Async function. What this basically says, it is a function that can contain await statements. Async functions, because they are asynchronous, always return a promise. Don't believe me? Let me show you. Async function return 1, 2, 3. Actually, let me give this a name too. Async function foo. So foo is an async function. I'm going to call foo. I get a promise. I didn't type anything related to promises in here, but because it has that async keyword, it will always return a promise. And now if I do .then on it, I get 1, 2, 3. So what's cool is this is where the line between things that are inside of promises and things that are outside of promises gets to start to be blurred. And that becomes really powerful when you can basically treat, from a really high level context, you can treat everything like a promise. And then from an inner context, you can treat everything like a value. Like I'm returning 1, 2, 3. I'm not returning like a promise that contains 1, 2, 3. And sort of the code can be smart and figure out if this is a value that's going to exist later. I can process this thing later when it exists. Or if it's a value that exists now, I can process it now. And JavaScript figures that out for you. You don't have to think about it. And you can just say, whenever this value becomes available, whether it's now or later, do this thing. So the async function has to exist in order for this to work because so returning the value of a promise is like keeping the promise. Yeah, exactly. So if I were to let's say let me go to module5.ml here so I can do something with Axios and give you a real thing. If I do like axios.get here, module5.ml, good old fruit, make a request here. And then I call foo. I'm going to store the value into my var, sure, whatever. So my var is a promise. It is not a promise within a promise. It's not 2 levels of promise. It's just 1 level of promise. And if I go my var .then, totally does what you think it would do. It logs out the data that is in the promise that is returned by axios.get. Yeah, this is pretty nuts stuff. Okay, let's do so because we're talking about async await, let me give you a lot more real demo of this. Also, I'm realizing I haven't really been giving demos as I've been going of this working, but I think it's been theoretical enough where it's been fine and people seem to be getting it, so I guess it's okay. So I'm going to do response is equal to await this, and then maybe I'm going to do like I don't know, return response dot status divided by 2. This is super contrived, I know, but like the point is, I wrote this synchronously. Like I'm treating this as if it's synchronous. I'm doing something like synchronously here. There's no dot then. All I have to remember is that I put an await in front of anything that returns a promise, and I have to put all that inside of an async function. As long as you follow those two rules, and I run foo, remember, I'm going to get a promise because it's an async function, but if I then do dot then on that and kind of unwrap the promise, I'm going to get 100. 200 divided by 2. So it's this kind of mixing together the async and the synchronous code together using await kind of as that bridge. So yeah, that's async await. It seems like people are actually kind of getting this, which is pretty neat. But don't feel like you have to get this. Like this is a total stretch goal. Like the dot then training, the chaining of dot thens is a stretch goal. This is like a stretch goal. So Carolyn asked, how common is async await used? All over the place in real code. Like, I will be honest, the last time I wrote a dot then was months ago. Like, pretty much exclusively async await. I should know this, but I don't. I'm not sure what Joey's going to use with you. I'm going to push him heavily to use dot then just because it's going to be, for maybe those who don't understand this, it's going to be a lot simpler to wrap your head around. Like, just because this, sure, maybe you can wrap your head around this, like looking at the code, but when you actually have to talk about what's going on here and you have to debug this, you're going to have a lot harder time if you don't have a deep understanding of promises. So yeah, in real code, it's exclusively this. And actually, the other thing that we use a bunch at work is what are called observables, which are kind of like another step on top of this. Which, like, I'm not prepared to go into that today. Those are still something I am working on and don't have a full grasp on. But are really, really powerful. Okay, one little thing I'm going to mention about them. Imagine a promise that can resolve multiple times. That's an observable. I'll let anyone who wants to let that mess with their brain have that happen, but yeah. Okay, actually, there is one more thing I should mention. Not observables, just with promises. We've so far talked about stepping all the way back. Not async await, not even the chaining dot thens, just going back to like the very simple example of like a promise, you call dot then on it, you give it a callback. When the callback runs, the callback will run once the event, the completion event or the resolving happens. Going all the way back to that. What are observables? Carolyn, don't worry about what observables are right now. If you really want to know, Google it. And be ready to have your mind blown.
The librarian in me probably will when I have time. No, I thought it was something I was supposed to know, and I never heard the word. Okay, it didn't happen. All right, thank you.
Saying it because some people here are going to want to look into it because they're crazy.
Well, that would be me when I have time.
Yeah, feel free to, but like that is way above and beyond what you're going to need to know for this whole class. I will say that I'm somewhat fluent with observables. Gus is somewhat fluent with them. I don't know if any other instructor is. So like, and other instructors, if you're watching this later on, feel free to correct me. I just know that Gus and I use them at work. So we're fluent with them, or somewhat fluent with them at least. So yeah, like you're probably, what I'm trying to get at is if you look into them, be prepared to have your mind blown, and also be prepared to ask questions of instructors and them not know how to help you.
And one more thing about async await before you move on, or finish your sentence. I'm sorry.
Oh, I was just going to say, like, and I just want to make it very clear. You do not have to look into observables. They are not something you're going to be like quizzed on or tested on or like asked about. I'm just mentioning it because people might be curious. So like, you do not need to, or even like you shouldn't look into observables. I would go that far. But sorry, Kyle, go ahead.
I was just going to say that adding the async half of that answered my previous question, that when you put it inside of a function, then you can write other code after.
Yeah, that
was what I was confused about. So I just asked the question too soon.
Yeah. But within the actual async function itself, you can't. And that's why I had to use
that's more workable. I was like, how are you not going to be able to write anything in the entire file after that? It ends when the async function ends, and then you can write other code beneath. So that's helpful.
Yeah, and I couldn't do here await foo. Like at the very top level, you have to have a dot then. Like you can't use async await for the whole thing. You have to have a dot then at the very end, just so like, so you've got to have at least once to like invoke your first async function. Okay, I'm really going off on a crazy tangent here, but I will mention there is a new proposal out in JavaScript that actually maybe isn't so new anymore to allow you to do top level awaits in files. So basically allowing you to do awaits not within an async function. I haven't really played around with it. I don't know the details, but I wanted to mention that just for completeness, that like people are even going the step further of like, how could we just get rid of then entirely and have it all be async await everywhere throughout the whole code base? Yeah, new proposal from the TC39. I don't think it's even all that new anymore. I don't think it's like, this probably doesn't mean anything to you, but I don't think it's in stage 4 yet. I think it's still kind of earlier on. But yeah, it's gonna be a brave new world. But okay, actually, before I change gears a little bit here, anybody else have any questions about async await? Okay. So the other thing I wanted to mention about promises is that there is a possibility for a promise not to actually resolve and for it to do what's called rejecting instead. So imagine that going all the way back to our like parents nagging the kids or kids nagging the parents analogy. Imagine the kid tells the parent, okay, let me know when we get there. And the parent says, okay. And then the parent just decides to like drive to somewhere else completely. And then the parent says like, psych, we didn't actually go there. That's kind of what rejecting is. So promises, they can do one of two things. When you create a promise, promises have 3 states, like their pending state, a resolved state, and a rejected state. So in general, we can assume in this module, at least, that all promises will resolve. Will get that dot then will be called, to be clear, that dot then only gets called when they resolve, not when they reject. And we can assume that every time you make an HTTP request, it's going to be successful, that the server is not going to be down, that like there's not going to be something weird going on in the user's browser. But in the real world, you never really write a dot then without also writing a dot catch. So that's the other thing. Back over to the code here. If I were writing this code in the real world, I would stick at the very end of all this a dot catch. Sorry, not going to use arrow functions, going to be disciplined here. And in this dot catch, I would then say like, uh-oh, and log out my error. And what happens here is basically, if at any point during this, like let's say delay for some reason decides it wants to fail. Like delay is a bad example here because like how's a delay gonna fail? Like there's not really much to go wrong there. But maybe more in practice, like an HTTP request, like that fails. Like it tries to run, the browser tries to do the equivalent of running nc module 5.ml 5000, and like that command were to fail. Like that's like an example of like a failure case. But that fails. Then this promise is going to reject, or this promise is going to reject. And what's going to happen is like all these dot thens, all those like dominoes that you set up, they're not going to get called because like this promise never resolved. What's going to happen is you kind of have like a parallel set of dominoes that you've set up that will get run whenever the promise throws an error, or rejects is the term they use. And the way there's sort of a pattern here where you tend to put the catch at the very end after all the dot thens. You don't do something like put a catch in here, like, or like a catch here. Like you don't put like lots of catches all over the place. You tend to put one catch at the very end because a neat little thing is if this promise were to reject, then it's going to, that sort of rejection is going to bubble up and it's going to eventually hit this catch. So if you put one, like if you had your whole program was all within like async await or was all in this promise syntax, if you put one catch at the very end, anytime any error in your whole program happens or anytime any promise in your whole program rejects, this catch is going to be called. So it's kind of a typically what you'll do when you write with promises, you'll have one catch at the very end. And then in the couple places where maybe you want to handle an error in a special way, you'll have an inner catch. So maybe like you'll have like one here, and maybe you want to handle like the special delay error case in like a special way. Maybe you want to like retry the delay or something. That's where you'll do it you'll have like special catches in each bit. But as a general rule, you want to put catches at the highest level possible. So because we're talking about all this and because we talked about async await, you might wonder, how do you do a catch in async await? Like there's not really a .then to chain the catch onto. Like where do you put that? Well, the answer is JavaScript people have gotten real clever. And what they've decided is basically, probably all are familiar with the try-catch syntax. Like you can put code in here. I'm assuming. If you're not, please speak up and let me know. Like you can put code in there, and if the code fails,
I need your view.
Okay, let's quickly review that then. So let's say you've got code. Maybe okay. We're going to make a function called divide. We're going to make a numerator and a denominator, and our numerator over a denominator. That's what it's going to be. And 4 divided by 2 is 2. Yay, it works like we think. But of course, when you divide, you can never divide by 0. That's a big problem. And in JavaScript, it returns infinity. Yeah, whatever. Forget about that. But the problem is, though, you want to somehow, well, oh, crap. Actually, it returns infinity. It doesn't throw an error. I work in too many programming languages, and I forget what JavaScript does and what other programming languages do. Okay, what's something that's going to throw an error in JavaScript? Accessing a variable that doesn't exist will throw an error. Okay, forget I just did that whole divide thing. That's not going to work. Let's say try catch is a syntax level feature in JavaScript that allows you to run code, and if that code throws an error, for you to run more code to handle that error in a special way. The way you do that is there's two parts. There's like two major pieces. There's a try piece, so it's try, and then some curly braces, and then catch, where you put an error, like you put a catch thing, and then you can put any sort of code you want to run when the error happens inside of here. And then just kind of like similar to like a function where you can define a bunch of values that get assigned when the function's called. Here, this will be assigned when with the error that has been caught. So for example, like this is not valid JavaScript. Well, okay. Guess syntax error isn't going to quite do what I want. There, that's going to throw an error because this like food is not a function. Oh, I already defined foo in this file. Okay, there we go. So foo is not, it doesn't exist. So when I try to access foo or I try to call foo, it's not going to work. So it logs out that error. Great. Sounds like this is probably already reviewed, but that's what try catch does. Now, what is cool is you can, where did it go? Not too many tabs open. The async await people have decided that they're going to, because await is like async or language level features, you can do some fancy language level things. And one of those fancy language level things you can do is if you wrap a try catch around something, if you wrap a try catch around something that has an await in it, if this promise rejects and that rejection hits the await is going to notice that. It's going to say, oh, am I in a try catch? And if it is, it's going to cause that rejection to bubble similar to how errors will bubble. And it will hit the try catch and it'll actually call the catch. Now, this is in addition to it still maintains the same functionality where if like an error were to be thrown in the try catch, it'll also handle those too. But this is kind of powerful because it means promise rejections and errors are handled in the same sort of way. And it kind of is just one more way you can sort of get rid of this, like the special things that promises have. Like you can kind of treat the values in a promise and like you can treat all the promise stuff in a synchronous way. Because if this actually failed, what would this probably do? It would probably throw an error. It wouldn't reject. So you could do what you'd think you need to do normally in a synchronous context, only it's async code. So it's kind of neat that you can do that. This can be a source of bugs. I definitely have run into situations where I've had things reject where like I'm calling a function and then a thing rejects from the function I'm calling, but that function's being called in a try catch. And like now that promise makes its way over to that try catch and that causes a code path to be taken that I wasn't expecting. Like that can definitely happen. But all in all, this is a pretty clever and smart way of handling it, if I had to say so. So yeah. Again, all this async await stuff, like don't worry about it. It's not something you need to be focused on right now. But some folks seem to be getting it, some I'm mentioning it. That's how promise rejections are handled in async await. Yeah, I think that's sort of about promises. There's not really much more going on with them. Yeah. Any other questions? Sounds like not.
Well,
yeah,
I did have a question a couple back. I thought you had said that the catch comes higher up in the function, but then it was like at the end, and I just got confused by that because
when you say catch, do you mean this or do you mean this? In this case, you want the catch to always go, or as a rule, you want to put the catch at the highest level possible. And that's what you want to do when you're using the sort of .then promise syntax, the syntax that I'm expecting you to probably use throughout the entire careers in code.
That's at the highest level in that example? Because
it is.
I'm confused because it's last.
It's last. And the reason why I say it's at the highest level is because something that's not at the highest level would be like in here.
Okay.
And by highest level, I mean it's on the promise that is the furthest at the furthest least indented, I guess.
It's the highest in the whole function, not the highest from top to bottom. See, my brain is still thinking, not like a machine. Okay. And in the other example, it's the same way. It's in the same position, correct?
In general, yes. This
except it's inside. Oh, okay. I don't want to know. I'm confused now. Okay. Thank you. It's like it really is a whole different language, and I don't mean computer programming language. It's like a whole language.
Yeah. Well,
its own
promises
weirdness.
Is like promises is like a whole different sub language in the language.
Oh yeah, you got this whole. Oh my goodness. Well, thank you. That helps because I'm thinking he said higher, and I'm thinking like. Going up the screen is like no, you got to remember what happens with the function, how computers think, and I still keep forgetting. Someday I'll remember. Thank you.
Yep. Yeah, I mean, I'm thinking about like other things with promises, but I think I've pretty much been through all of promises. Like there's Actually, okay, there is one more thing. I don't know how, like, it is totally valid for you folks to tell me to shut up at any point here. Like, I can just keep on going and going and going. So there's one thing we didn't talk about with promises, which is like, what if you want to run two things at the same time? Like, you want to make two requests concurrently. That's totally a valid thing you could do. Like, basically, like, let's say you've got like promise 1 and then like promise 2, and these are both happening at the same time. But then like you want to extract the value out of both of these promises kind of as a pair. Like, you want to say, I want both of these to run, and then once if both of these have completed, then I want to do a third step. So sort of like you need a bunch of asynchronous things to happen, and once they've all completed, you want to do a synchronous thing.
I'm sorry to interrupt, Brian, but should promise 2 maybe be changed to a different path?
Oh, it could be.
Because
Yeah.
to kind of so it's like, because it's like it's doing the same thing. But yeah, I mean, I don't know, just it doesn't actually matter, right?
Yeah, it doesn't actually matter. You're right in the real world, though. That's how you do it.
Well, yeah, I just want to understand it. That's all. Thank you.
Yep. Now we haven't really like, how do you join two promises together? Because that's kind of what you've got to do here, where you've like got to somehow get the data in promise 1 and promise 2 together. Like, you want to almost get like a dot then on like both of them combined. And there isn't like, you can't do like P2 plus, like, you can't do something like that. Like, because this is kind of what you want to do, like something kind of like that. Well, there's a way you can do this. And remember this promise, big uppercase P promise, the type of all these promise instances here? Well, uppercase P promise actually has some functions available on it. So there's these all these sorts of functions you can access. These are sort of like utility functions, and one of them is this all, and it's another one of these native code things. But promise.all takes an array and returns a promise containing all those values once they've all resolved together. So what this means is I can do like, let's say P1, P2, and this I'm going to call combined. Now combined, I can do dot then on, and what do you think this is going to have in it? Like, somehow it's going to be data from both promises. So we get an array, and that array corresponds to where the P1's data is here, P2's data is here. So what you end up doing a lot of is something like this, where you, well, we already got combined, but you end up doing something where like you say data 0, data 1, you extract them out, and then you do what you want with both of those at that point. Some people might ask, well, why don't you just do the dot then separately? Well, that's not going to work if you have code that depends on the data from both promises. So the dot then separately allows you to somehow like take a promise and kind of cause it to branch, to do like code or to run things for each promise in specific, or maybe to if you have like dot then twice on something, you could cause code to run, some bit of code to run, another bit of code to run, them to both run when the thing resolves. But if you want to do the opposite, where you take two promises and join them together, that's where you've got to use this dot all thing. A good example of this is like, let's say you have a web page, and when it loads, you want to make 5 requests to 5 different URLs to get 5 different sets of data. And then once all those 5 requests come back, you want to do something like show all that data to the screen. But maybe the data you're showing to the screen depends on that. Like maybe those five things all return 5 numbers, and you want to add all those numbers up, and then you want to show them on the screen. In order to do that, the most straightforward, easy to think about way would be like get all those requests once they've all completed, take all those that data, add all those numbers together, and then show them on the screen. There are other ways you could do it, but like that sort of pattern of like that sort of like you have a bunch of things going on, and they all join together is a pretty common thing you'll do. I promise that all is how you make it happen. There are a couple more of these utility methods on promise. I will say though, looking through here, use all the time, used all settled a few times, never used race. Reject and resolve, I use a bunch, but I'll talk about those in a second. But literally everything else I've never used. All settled is basically all, but just a little bit fancier. Race, I've never used. Basically, it's the same thing as all, only it will return the first promise that resolves, not all of them. Yeah, it's probably useful, but I've never run into a situation where like I've actually needed it. Reject and resolve, these are pretty handy. So these are, let's say you just want to make a promise that immediately resolves with a value. You can use promise.resolve and it'll do that. Or a promise that will immediately reject with a value. You can do that too. And really the reason why you need to do this is if something, for example, you have a place or like a place where you need to insert a promise, maybe like you have a function that accepts a promise for some reason, like as one of its arguments, and you need to give it a promise. You need to wrap up your value in the promise wrapper. This is sort of a way you can do that programmatically. With async await, I really have not had to use this all that often because like await, that's actually something else to mention. Await, if you say await something that isn't a promise, I'm pretty sure it'll just kind of transparently proxy that through. So await kind of will end up doing this for like, you don't really need to wrap things because await always unwraps things. Like, so I don't know. Yeah, I use these occasionally. Promise.all I use all the time. All the rest of them, it's like really like either between never used to like use them once or twice ever. So yeah, that really is like all of promises. I can't think of anything else that people do with promises on the web. Like we pretty much covered 100% of it. So way more than I was expecting to talk about, that's for sure. But I'm glad this is kind of as a video and people are going to be able to watch this and have a good like promise introduction. So yeah, that's about it. Have fun doing your weekend exercise. If you have questions for me, let me know. But otherwise, I think that's about all I got. So see you folks on Monday.
Thank you, Ryan.
Yeah.
See you guys later.